Hello and welcome back to the channel Science, Maths and Engineering. Today we are going to solve this mechanical engineering paper, the examination for which was conducted by the Directorate of Technical Education Assam for the post of Assistant Professor in 2020. As we have already discussed, all questions of this question paper were from the previous year GATE question papers and a pie chart is shown to show the number of questions from each year. So let's get started. For the stability of a floating body D, A. Center of buoyancy must coincide with the center of gravity. B. The center of gravity must be above the center of buoyancy. C. Metacentre must be above the center of gravity. Or D. Center of buoyancy must be above the center of gravity. So the answer is C. A floating body is said to be in stable equilibrium if a small displacement produces a couple which tends to restore the body to its original position. Okay. So for the stability of a floating body, the metacentre must be above the center of gravity. Next, consider the following partial differential equation for u xy with the constant c greater than 1. Del u by del y plus c del u by del x equal to 0. So solution of this equation is, you need to find the solution for this equation. You see, let u is equal to f of ax plus by. Therefore, del u by del of ax plus by is f dash of ax plus by. Now, if we come to the equation, so del u by del y plus c del u by del x equal to 0. We can write it as del u by del of ax plus by into del of ax plus by by del y plus c into del u by del of ax plus by into del of ax plus by by del x is equal to 0. So del u by del of ax plus by is f dash of ax plus by. So we have f dash of ax plus by into b plus c into f dash of ax plus by into a, which is equal to 0. Now if f dash of ax plus by is not equal to 0, then b plus ac is equal to 0, from which implies b is equal to minus of ac. Now if a is equal to 1, then b becomes minus c. So our u of x plus u of xy is equal to f of then x minus cy, and it is a solution. So u we considered as ax plus by, a we were considering 1, and b we get that as minus c. So it becomes x minus cy. Okay, next question. A simply supported beam of width 100 mm, height 200 mm, and length 4 meter is carrying a uniformly distributed load of intensity 10 kN per meter. The maximum bending stress in megapascal in the beam is, so we need to find the maximum bending stress. So the answer is, so we first convert the figure into a free body diagram. Here we have RA, RB at points A and B, and this uniformly distributed load is along L length, so it is WL, and it is acting at the center, that is at L by 2 distance from both A and B. Now R of A plus R of B would be equal to WL, so summation of the vertical forces are 0. So that is one equation. Next, the moment at the point A would be 0, so WL into L by 2 would be equal to RB into L. From here we get RB is equal to WL by 2, and so putting this again in the first equation we get RA is WL by 2. Now suppose we have a point A here at a distance x, we have a point A, we need to find the bending moment at this point. Okay, so if we consider only this portion, we see that this has a uniformly distributed load of Wx acting at a distance of x by 2 from both this side, left side, and the right side. Now mx would be equal to Ra into x minus Wx into x by 2. So which becomes WL by 2 into x minus Wx square by 2. Now for maximum moment, dm by dx is 0. So this becomes dm by dx becomes WL by 2 minus Wx. So dmx by dx becomes WL by 2 minus Wx is equal to 0. So which implies x is equal to L by 2. Therefore maximum, m maximum would be equal to how much? W L by 2 into x is L by 2, then w into x square, so L by 2 square divided by 2, which becomes WL square by 8. Now again we have sigma by y is equal to m by I, where sigma is the shear stress, y is the most distant point from the neutral axis. That means y would be equal to radius, and then m is the bending moment and I is the moment of inertia or the second moment of area of the section. So y we already know it is r, that is d by 2, so it becomes 0.1 meter. I would be bd cube by 12, so it is 0.1 into 0.2 whole cube divided by 12, so it is 2 by 3 into 10 to the power minus 4 meter to the power 4, and m max would be ws square by 8, so it is equal to 20 kilonewton meter. So sigma max would be m max into y divided by I, so it comes out to be 30 megapascal. Next question. The internal energy of an ideal gas is a function of A. Temperature and pressure, B. Volume and pressure, C. Entropy and pressure, and D. Temperature only. So the answer is it is a function of temperature only. Next, the demand of a two-wheeler was 900 units and 1030 units in April 2015 and May 2015 respectively. The forecast for the month of April 2015 was 850 units. Considering a smoothing constant of 0.6, the forecast for the month of June is, so this is a forecasting problem. So the answer is, see, the forecast for a particular month is equal to the forecast of that month plus the forecast of the previous month plus the smoothing factor into the demand of the previous month minus the forecast of the previous month. So we have forecast of May would be equal to forecast of April plus alpha into demand of April minus demand forecast of April. So it becomes forecast of May is 880 units, and so forecast of June would be 970 units. So our answer is 970 units, that is option A. Next, assuming constant temperature condition and air to be an ideal gas, the variation in atmospheric pressure with the height calculated from fluid statics is, so the answer is C. Let x be the height from the ground at which the variation of the pressure is calculated. Now as we go up, so the pressure decreases, so our del p by del x would be equal to minus rho g, because as x increases it is rho g x is the pressure, and if it's for a height h then it is rho g h. So therefore del p by del x would be how much? It is equal to minus of rho g. Now as the temperature is constant and air is an ideal gas, so P is equal to rho RT, which implies rho is equal to P by RT. Now dP by dx would be equal to minus rho g, so instead of rho we can write P by RT into z, which implies dP by P is equal to minus of g by RT into dx. So integrating both sides we get log of P is equal to minus g into h divided by RT, as x is from what? 0 to h. So which implies that P is equal to e to the power minus gh divided by RT. So therefore the variation in atmospheric pressure with height calculated from fluid statics is exponential. Next, a point mass having mass capital M is moving with a velocity capital V at an angle theta to the wall as shown in the figure. The mass undergoes a perfectly elastic collision with the smooth wall and rebounds. The total change, final minus initial, in the momentum of the mass is, so the answer is C. It is a perfectly elastic, so angle of incidence would be equal to the angle of reflection. So this is theta, and this would also be theta. Now if we see, initial velocity would be what? V cos theta is the horizontal component. So V cos theta I plus vertical component is V sin theta. So plus V sin theta j. Final velocity is this one. So it is V cos theta I, and it is negative now. So minus V sin theta j is the y component. So change in momentum is equal to mass into change in velocity. So m into Vf minus Vi. So we get change in momentum is equal to m into Vf minus Vi. So we get cos theta gets cancelled. So we have minus 2V sin theta j. So which is equal to minus 2mV sin theta j. So next question. A cantilever beam of length L and flexural modulus EI is subjected to a point load P at the free end. The elastic strain energy stored in the beam due to bending is, so the answer is, see here we have the load P at point B, and this is the fixed point A, fixed and A, and so this length is L. Okay, now let us take a section 1 1 at a distance x from B. So we see the elastic strain energy due to bending is given by U is equal to integration of m square dx divided by 2ei. Now at this point 1 the bending moment is how much? P into x, right? So total strain energy U would be equal to how much? 0 integration of 0 to L m square dx divided by 2ei. Now m square is P square x square. So P square x square divided by 2ei into dx. So P square by 2ei is constant. So it becomes x cube by 3, or we get U is equal to P square L cube divided by 6ei. So our total strain energy is P square L cube divided by 6ei. Next question. Which two of the following joining processes are autogeneous? We have diffusion welding, electroslag welding, tungsten inert gas welding, or friction welding. And then we have combinations in our options. So we will see which combination is correct. So you see diffusion welding and friction welding are the joining processes here which are autogeneous. So let us see. So in autogeneous welding, no filler material is used during joining. All types of solid phase welding, that is forge welding, butt welding, oxyacetylene, pressure welding, flash butt welding, friction welding, and some resistance welding such as spot welding, projection welding, seam welding are examples of autogeneous welding. Now some kinds of diffusion welding are also autogeneous welding, while some others use filler material. Now in diffusion welding, the filler material is used to reduce the operating temperature and pressure and to permit the use of a normal atmosphere instead of a vacuum atmosphere, as we know that vacuum atmosphere is very expensive. Okay. Now electroslag welding uses filler wires and flux, and tungsten inert gas welding uses filler material when needed. So our answer is that friction welding and diffusion welding are autogeneous. So option B is the correct answer. Next, figure shows a wheel rotating about O2. 2 points A and B located along the radius of the wheel have speeds of 80 meter per second and 140 meter per second respectively. The distance between points A and point B is 300 millimeter. The radius of the wheel in millimeter is, the answer is, see, let the radius of the wheel RB is equal to O2B, and let the radius of the point A be O2A. Now RB minus RA is how much? It is 300 millimeter. The velocity of the point B, VB, is how much? RB into omega 2, right? This as the angular velocity is omega 2, and velocity of the point A would be VA is equal to RA into omega 2. Now VB by VA is then RB by RA. Now therefore RB by RA would be what? VB is 140 and VA is 80. So it is 140 by 80, that is 7 by 4. Which implies RA is equal to 4 by 7 RB. Now we know RB minus RA is 300. So we get RB minus 4 by 3 of RB is 300, or we get RB is equal to 700 millimeter. So our answer is that the radius of the wheel is 700 millimeter. Now note, in some questions you may be asked the diameter also instead of the radius. So then it will be 1400 millimeter. Okay, next question. A machine element XY fixed at and X is subjected to an axial load T, transverse load F, and a twisting moment T at its free end Y. The most critical point from the strength point of view is, so the most critical point would be the point where the failure chances are the maximum. So let us see. See, we have sigma by Y is equal to M by I. So sigma would be equal to My by I. Now here Y is what? D by 2, and Di are constant for the cylinder. So maximum shear stress occurs at the location as the maximum moment. Okay. So what is saying that Y and I, they are constant for a cylinder. So only M is changing. So maximum shear will occur at the location where this M is maximum. Now M is equal to how much? Force into this distance xy. So force F into this distance xy. Right. And the moment is maximum at the fixed end, then because F into xy. So moment, if this point would have moment is what? Force into the distance from this fixed end. So maximum would be at this point only. So at this end x, it has the maximum moment. So sigma would be maximum at that end. Again, T by J is equal to tau by R, which implies tau is equal to TR by J. Now J we know as pi dt by 4 by 32. T is the torque and R is the radial distance from the centroidal axis. So torsional shear stress tau is maximum where? At the circumference of the cylinder. So even for this tau also, the maximum is where? At the circumference of the cylinder. So at y or x or anywhere at the circumference it will be maximum. Okay, so from this we till now we can see that the maximum is happening here at the end x and the circumference of the cylinder. Now let us see what happens to the axial load. So the shear force due to this tensile force P is given by P by A. Now cross section of this whole cylinder is constant, so the shear force due to the tension is constant along the cylinder. So our most critical point from the strength point of view would be a point where? Would be a point at the circumference of the cylinder and at the location x. So it is option A. Next question. The solution to the system of equations 2, 5, minus 4, 3, xy is equal to 20 and minus 30 is, so see, this kind of problems can be done in two ways. First one, that is the traditional method. I am showing this because we may have to do any kind of matrix calculation, so this is required. So how we can do? This is ax equal to b, so which implies that x would be equal to a inverse b. Now x is here, xy, a is 2, 5, minus 4 and 3, and b is b is 2 and minus 30. So a inverse is what? 1 by the determinant of a into adjoint of a. Determinant of a is 2, 5, minus 4, 3, so we cross multiply, so it is 2 into 3 minus of minus 4 into 5, so we get 6 minus 20, so it is 26. Now adjoint of a would be, adjoint is 2 comes here, 2 comes here, 3 comes there, and this becomes minus and this becomes plus. So if m is equal to a, b, c, d, then adjoint of m is d, a, and this is minus b and minus c. Okay, so x is equal to how much? A inverse b, so it becomes 1 by determinant of a into adjoint of a into b. So 1 by 26 into 3 minus 5, 4, 2 into 2 minus 30, so it becomes 1 by 26 into 3 into 2, 6, plus 5 into 30, 5 into 30, so it is 150, so it's 6 plus 150. Then here 4 into 2 is 8 and plus 2 into minus 30, so it becomes 8 minus 60, so it becomes 1 by 26 into 156 by minus 52, or 6 by minus 2. So our answer is x is equal to 6 and y is equal to minus 2. Now we can also do it by trial and error method. What we do, we put, first option is x equal to 6 and y equal to 2, so we put 6 and 2, so we then multiply, then we get 22 and minus 18, so it is not equal to the right hand side, so it is not correct. Next option again we check, so this is again minus 2 and 30, we should get 2 and minus 30, so it is wrong. Third option again we try, you get minus 22 and 18, so it is again wrong. And the fourth option, x equal to 6 and y equal to minus 2 is the correct answer, so we get left hand side equal to right hand side. So in exam the second method is maybe you can prefer more because it is faster. However, if these matrices are complicated, then we can use the first method. So next question. A gear train is made up of 5 spur gears as shown in the figure. Gear 2 is driver and gear 6 is driven member. N2, N3, N4, N5 and N6 represents the number of teeth on gears 2, 3, 4, 5 and 6 respectively. The gear or gears which act as idler are, so the answer is C. An idler is used to change the rotational direction of the output shaft or to fill a large gap between the input and the output shaft without affecting the speed ratio. So because of this idler, there would be no speed ratio change. Okay. Now see here, 2 once it is moving, so 3 is a bigger wheel. So 2 to 3 there will be a change in the gas speed ratio. Now because they are attached to the same joint, same shaft, so what happens is that now with this RPM of this third wheel would be the RPM of the fourth wheel. Now as fourth wheel is connected to fifth wheel, so this will transfer the rotation to the fifth wheel, but again fifth wheel from here again sixth wheel comes, so basically what happens is that the RPM, the change, this fifth wheel, even if it is not there and 6 comes directly in contact with 4, then also this RPM of this sixth wheel would be same. So N5 is this wheel 5 is the only one which doesn't have any impact, so it is the idler. Okay. Now, had there been one more gear here, instead of after 5 and between 5 and 6, had there been one more gear, that would have also been an idler. It would have changed the direction, but the speed ratio would have not changed. So next question. Link 2 rotates with constant angular velocity omega 2. Link 3 moves outward with a constant relative velocity VQP, where Q is a point on the slider and P is a point on link 2. Okay. The magnitude and direction of Coriolis component of acceleration is given by. So this is a very basic question of theory of machines. So the answer is, see, the magnitude and direction of the Coriolis component of acceleration is given by 2 omega 2 into V of QP, and the direction of VQP rotated by 90 degree in the direction of omega 2. So V of QP is rotated by 90 degree in the direction of omega 2. Okay. Now this magnitude of the Coriolis component is positive if link 2 rotates clockwise and slider moves radially outward, like this condition, or if the link rotates anti-clockwise and the slider rotates radially inward. Okay, so in those cases this Coriolis component is positive. However, had this been going outward and this is in the anti-clockwise direction, then the value would have been negative, and or this is same but this direction is inward, then also the value of the Coriolis component would have been negative. Next question. A circular object of radius r rolls without slipping on a horizontal level floor with the center having velocity v. The velocity at the point of contact between the object and the floor is, the answer is, see, this is the figure. So we need to find out the velocity of this point A. Now as this point velocity v is in contact with the floor, so this velocity is 0. Okay. So the next point comes, so that velocity would be 0, but at this instant the velocity of this point A is 0. Next question. Laplace transform of cos omega t is, the answer is, it is s by s square plus omega square. So I have given the Laplace transform of some of these basic functions. So Laplace of 1 is 1 by s. Similarly, you can see that Laplace of cos of alpha t is s by s square plus a square. So our cos omega t would be s by s square plus omega square. Next question. A small ball of mass 1 kg moving with a velocity 12 meter per second undergoes a direct central impact with a stationary ball of mass 2 kg. The impact is perfectly elastic. The speed in meter per second of 2 kg mass ball after the impact will be, so it is from engineering mechanics. So let us see. See, mass is given, m1 is given, m2 is given, u1 is given, u2 is 0. Now as the impact is perfectly elastic, so our coefficient of restitution would be 1. So E is equal to how much? Velocity of separation by velocity of approach. So v2 minus v1 divided by u1 minus u2 is equal to 1, from which we get v2 minus v1 is equal to u1 minus u2. Now v2 minus v1 would be, u1 we know 12 and u2 is 0, so it is 12. So we can write v1 is equal to v2 minus 12. Again, from the law of conservation of momentum, we have m1 into u1 plus m2 into u2 is equal to m1 into v1 plus m2 into v2. So we get 1 into 12 plus 2 into 0 is equal to 1 into v1 is what? v2 minus 12 plus 2 into v2. So from here you get v2 is equal to 8 meter per second. So the speed of the 2 kg mass ball after the impact will be 8 meter per second. So next question. Which one of the following statements is true? A. The no-go gauge controls the upper limit of a hole. B. The go gauge controls the upper limit of a hole. The no-go gauge controls the lower limit of a hole. The go gauge controls the lower limit of a hole. Or D. The no-go gauge controls the lower limit of a hole. So let us see. See, this is for hole and this is for shaft. This is go and this is no go. Similarly, this is go and this one is still here, from here to here it is no go. So the no go gauge controls the upper limit of a shaft, not a hole. Then the no go gauge controls the lower limit of a shaft. The go gauge controls the lower limit of a hole and the no go gauge controls the higher limit of a hole. So our options B and C are the correct options. Okay. So as this was from gate actually, so we generally sometimes have more than one correct option. So next question. A box contains 4 red balls and 6 black balls. 3 balls are selected randomly from a box, one after another without replacement. So it is without replacement. The probability that the selected set contains 1 red ball and 2 black balls is, so the answer is C. Let R be the event of drawing a red ball at random and B be the event of drawing a black ball at random. Now, 1 red ball and 2 black balls can be taken from a box containing 4 balls and 4 red balls and 6 black balls at random without replacement as, like, first red ball and second black ball, third black ball, or black ball, red ball, black ball, or black ball, red ball, right? So probability of selecting any of these procedure is the summation of the probability of these individual possibilities. So from here we have first red ball, the probability is how much? 4 by 10, because 4 red ball and total 10 balls. Second black ball is 6 1, so 6 divided by 9, because we totally have 9 balls now. And third one would be, now it is 5 red ball, 5 black balls, so 5 by 8, right? Plus the similarly this is 6 by 10 into 4 by 9 into 5 by 8, and then 6 by 10 into 5 by 9 into 4 by 8. So we have probability as 1 by 6 plus 1 by 6 plus 1 by 6, or it is half. So this probability that the selected set contains 1 red ball and 2 black balls is half. So next question. A rod of length 20 mm is stretched to make a rod of length 40 mm. Subsequently, it is compressed to make a rod of final length 10 mm. Consider the longitudinal tensile strain as positive and compressive strain as negative. The total true longitudinal strain in the rod is, so the answer is, see, initial length we know 20 mm, final length we know 10 mm. Now true longitudinal strain in the rod is actually given by log of L2 by L1, so it is log of 10 by 20, that is minus of log 2, that is minus 0.69. Now sometimes we may get confused, as we may think that it should be 20 minus 10 divided by 20, so that is like 0.5, so that is not right. It is actually done as it is true longitudinal strain, so it will be log of log L2 by L1. Okay, so with this we have come to an end to the third part of this mechanical engineering paper, the examination for which was conducted by the Directorate of Technical Education Assam in the year 2020 for the post of assistant professor. So we'll come up with the next two parts soon. So stay tuned with the channel and see you in the next one.